So if you all remember the video I did about the Heston model, I was looking over that code and I figured there's some additions that I'm going to make to it, and there's some errors that I'm going to fix. So to start off, let's come up here. So I have an options chain URL up here, and I'm going to be using this to extract the implied volatility and feed that as the initial volatility parameter in the Heston model's volatility function. So, but before I do that, what I have to do is like, if we're in the get, we're using the get function to place the REST API request, but we have URL, which has the standard historical data from Polygon in here. So what we need to do is fix this a little bit. So instead of making ticker an argument, I'm going to make URL an argument, and then I'm just going to delete this. So now what I have to do is come down here, and where it says response equals get ticker, I have to put URL ticker. So now I'm going to go ahead and compile this. So that's going to be g++ new heston.cpp, set it equal to c++14, and compile curl. So it's gonna take a little bit because I just booted up the terminal, so it takes my MacBook like some time to like compile the thing fully. But just bear with me, it's gonna come true. Yeah, I probably have to wait like 10 more seconds. Okay, it compiled, so now I do /a.out. Okay, so it's working perfectly. So instead of Amazon, I'm gonna do Microsoft as the stock. So let me recompile this. Reset /a.out. Okay, so it's looking more bullish on Amazon. Oh, segfault core dumped. Okay, I'll keep this off for now. I just got rate limited for putting too many requests at once. So let's focus more on the implied volatility, which is going to come from this function op_url. So what I'm going to do is I'm just going to create a new main function, comment this out until it's ready to be filled in. Well, actually, before we even do that, we have to come here and we see theta is supposed to be the variance of the average volatility. So we have to get rid of this square root over here. Sigma is the volatility of the volatility. So theta is the variance of the average volatility, and sigma is the variance, no, is the standard deviation. So yeah, the volatility of the volatility, yeah. Before we get too confused here, let me, okay, yeah, so that's a fixed okay, I was just confusing myself. Okay, so everything's good to go here. Theta, sigma, kappa's fine. We don't need to do anything about kappa. So what I'm going to do here is define int main return 0. So let's go up here and see what we need. So op_url, we need a ticker, a side like call and put, and an expiration date. So the first thing I'm going to do is make the expiration date, and that's going to equal 2024 August 2nd. That's the format that the API takes in. And the ticker is going to be Microsoft. And then the side is going to be call and put. So I'll just simply do cout. Or rather, I think it would be better if we just create the parsing function as is. So let me come up here and minimize some of these functions. We already fixed that. We got Typhoon, JSON, computer, DWT. So over here, I'm going to do first I'll call it void. So void implied volatility. And it's going to take the argument of a ticker, and expiration. We're going to do the sides in here. So that's going to be string of call options equals get op_url, and the arguments for that are ticker, side, and expiration. So that'll be ticker, call, and expiration. And then I'll do another string, call it put options. equals get op URL ticker put expiration. So now what I'm going to do is create a ptree object. So ptree calls equals JSON of call options, and ptree puts is going to be JSON of put options. And then I'm going to create two vectors of price and imp vol. So then I'll do for ptree const iterator it equals calls.begin. It is not equal to calls.end plus plus it. So it'll be if it first equals last. This will parse all the last prices, so then it'll be for ptree const iterator jt equals it second dot begin. It is not, oh no, jt, I mean not it, so jt second dot begin. JT, no. This is IT, that's JT. So JT is not equal to IT second dot N plus plus JT. So this will be price dot pushback atof of JT second dot get value of a string dot c underscore str. And then I can do the same thing with the implied volatility just to make things faster. So I'll come here and do if this equals IV, this will be imp vol dot pushback the second value. So now I'm going to come down here and see how many, well actually, we should copy this loop and do the same thing for puts. We're going to aggregate the total, so it's going to be everything. So puts, and actually let's see where exactly, like what time we're using for this. So 30 days. Okay, maybe I should use the option which is in 30, which expires in 30 days. So puts. Okay, down here at the expiration. So let's go to the calendar and find the first Friday in 30 days. So today's the 25th. So 7/14/21. Yeah, we'll do it to August 23rd. Yeah, August 23rd. So that'll be 23rd. And then I'm going to call implied volatility here. So implied volatility of, what are the arguments? Ticker and expiration. And I'm going to print out the length of these right now. So that's going to be cout price.size and imp vol.size, just to make sure the data has loaded properly. So that'll be end line. So I'll come here, compile it, ./a.out. Yep, 120, perfect. So we have it. So now I'm going to declare total equals 0, and it's going to be for auto price, or the price in price total plus equals the price, and then here it's going to be double total, no, result equals 0. So then it'll be for int I equals 0, I is less than price.size plus I. So result plus equals the weight, which is going to be price of I divided by total times imp vol of I. And this is going to be our this is going to be our price weighted implied volatility. So so what we have to do is convert it to variance. Yeah, so then it's going to return the power of result squared. Okay, so that is our implied volatility function. So I'm going to minimize that. I'm going to just copy the expiration up here. So control V this into here. And then cut this out. Oh wait, before I do all that though, I need to make sure that the implied volatility is correct. So double IV equals implied volatility, C out IV and line. So compile that. Let me just make sure also in the request function. So JSON response. Oh yeah, I did the get URL ticker here, so that's good. Two errors. Okay, I'll just type this in here. So 2024-08-23. Let me compile this again. Oh, yeah, I forgot. Where to go? I gotta make this a double because it returns a value now. So compile that. Let me just make sure the Heston one is okay. Yeah, mean, average of the variance, volatility of the variance, and so forth. So now I'll come down here and do ./a.out. Okay, so we got the implied volatility aggregated across, no, implied variance, because I squared it. But yeah, let's, so let me minimize this, take this out, copy all of this here. So I'm just gonna do Control X, backspace, come over here and do get the implied volatility for a month's time. So that'll be, so I come here where it says 0.3, I do IV. So now let me compile this. Reset. A.out. Okay, so 91% of the simulation says go long, 9% stays short. Let's look at a different stock. Let's do Home Depot. Like Home Depot makes a lot of bread. So we can compile it up here. ./a.out. Long 69, short 31. Let me run it again. Well, let me wait like 1, 2, 3, 4, 5. Can't see me. A.out. Okay, so it's not as bullish on Home Depot as it is Microsoft. I mean, it kind of makes sense. Like Microsoft's at like the forefront of the AI game right now, so it's like, yeah, there's a lot of money in that. But yeah, I just wanted to show you guys like the fixing some of the errors in the code and like adding the implied volatility to this. And yeah, if you want to run this, you're gonna need to have a token API key from marketdata.app, and you're gonna need a API key from Polygon to get this working. But yeah, I thank y'all for watching this video. I'm glad I found these mistakes and additions to put in, so I feel like I did good. So yeah, thank you for watching. Peace out.